We're going to look at some stuff from 7B, go back and revisit some of that stuff, and then also kind of expand on what we have learned. Actually, this first problem here, suppose a fair die was rolled and a fair coin was tossed, was the probability of getting a heads or a two? You could do this a couple of different ways. You could list out all of the outcomes and figure out your favorable outcomes, but we're going to use the fact that this is an OR probability. And my reference sheet says that if I have an OR probability, I have to figure out if it's overlapping or non-overlapping. So when I am looking at getting a heads or a two, this is non-overlapping. You can't be both. And since I am looking at OR probabilities, I'm looking at the sum of the two probabilities. Probability of getting a heads is 1/2, then plus the probability of getting a 2, 1 out of 6. We add that together and we get 2/3. Part B, what is the probability of getting heads and a 2? So at first glance, it may seem like these are both the same problem, but here is OR, and here we have an and that makes a difference in what the problem means and how we do the problem. When I have an and probability, I'm going to multiply the two probabilities. Probability I get a heads is 1/2. The probability I get a 2 is 1 out of 6. So I multiply that together and I get 1/12. You need to be sure you understand the difference between these two. This is like saying a heads or two, either one will win. This is like saying I have to have a heads and a 2 in order to win. So two different meanings, two different answers. Problem number 2, what is the probability of rolling 5 fair dice and getting an even number on all 5? So I'm rolling the die 5 times. And if you want to think about it as 1, 2, 3, 4, 5 different things that I'm doing and the probability of each of those. Well, when I roll that first die, what is the probability that I get an even number? Well, 3 of the 6 are even numbers. If you know that's 1/2, you could write it as 1/2. And my second roll is 3, 6. And for the third roll, and the fourth roll, and the fifth roll, each of them have a probability of 3, 6. And this would be 3, 6 to the 5th power. And again, if you know that's 1/2, you can use that number in there as well. And that's going to give you 1 out of 32. Problem 3, we have a table here that shows the animals available for adoption at the local pet shelter. We have cats and dogs, male and female. What is the probability of getting a cat or a male? So I have an OR probability. I have to figure out if that's overlapping or non-overlapping. In other words, can a cat be a male? Well, yeah, they can. So that's an overlapping. I'm going to go ahead and write that down, even though they didn't ask me to do that. And I'm going to have to find the probability of getting a cat, the probability that it's a male, no matter what type of animal it is, and then I have to subtract off the male cats, subtract off that overlap. Probability of getting a cat. Well, first of all, I need to know how many animals there are altogether. And there's 18 animals altogether. Probability of getting a cat. Well, there's 9 cats and there's 9 dogs. Probability of getting a cat is 9 out of 18. The probability of getting any animal that's male, there's 7 male animals. So that's 7 out of 18. And then I have to subtract off the male cats. So subtract off 4 out of 18. And that gives me 2/3. In a 4-child family, find the probability of getting at least one girl. at least one, right? We have a formula for at least one. I'm going to come over here and write the probability of getting a girl is 1/2. The probability that it is not a girl is also 1/2. And my formula says I want 1 minus the probability that it's not going to happen raised to some power where that's the n child. Well, I have 4 children, so this is going to be raised to the 4th power. And I'm just going to go ahead and write that answer as a fraction, 15/16. Problem 5. Find the probability of getting red on both spinners. Okay, now this problem is different because I don't have this spinner divided up into equal sections. Just because there's 3 sections doesn't mean that the probability of getting red is 1 out of 3 because my sections are not divided evenly. So what I'm going to do is to go ahead and put in a dotted line here, and hopefully now you can see I've got 4 equal sections and 2 of those are red. So the probability that I get a red here is 2 out of 4. The probability that I'm going to get a red on this spinner is 1 out of 4. So I have to figure out, am I adding these or am I multiplying these? Well, I don't see the word and I don't see the word or in this problem, but you have to sort of read into that. Find the probability of getting red on both spinners. So I want a red and I want the second one to be red. So this is an and probability, so that means I'm going to be multiplying these. So that's going to give me 1/8 for my answer. Problem 6, consider the following group of songs. We have different types of songs and the number of songs. Find the probability of selecting 2 rap songs without replacements. First of all, I have to figure out how many songs there are altogether, and there's 50. 2 rap songs. The probability of getting a rap song is 10 out of 50. Now, I'm not going to replace the name of that song, so now I only have 49 songs to choose from. I have to pretend I got a rap song here, and there's only 9 of them left. And when I multiply that together, I get 9 out of 245. B says the probability of getting 2 rap songs with replacement. I'm going to go ahead and do this. I like doing this. With replacement, I know that they're both going to be out of 50. I like having my denominators written down first. It doesn't matter how you do it. That's just one little trick I like to do to keep my thinking straight on this stuff. Probability that it's a rap song is 10 out of 50. I put it back, so I have still 10 rap songs to choose from. So that's 1 out of 25. Determine the probability of selecting a rap or pop song on one draw. It's an or probability, so I'm going to be adding these 2 probabilities together. Probability of getting a rap, 10 out of 50. The probability that it's pop is 15 out of 50. And when I add those together, I get 25 out of 50. And that is 1/2. Now I could have done this problem different. I could have added the rap and the pop together Instead, that is 25, and just go straight to favorable outcomes over total possible outcomes. Problem 7. A bakery offers the following cupcakes for sale. We can see we've got different types of cake and different types of icing. When we add all this stuff up, we're going to get 50 different cupcakes. Pam will select 2 cupcakes at random to buy. Determine the probability that the first cupcake will be chocolate with chocolate icing and the second cupcake will be chocolate with vanilla icing. So we've got that and in here tells us and probabilities. We have to figure out, is it, dependent or independent? Am I replacing it or not? Well, she's going to buy the 2 cupcakes. So when she puts the first one, of course she's not going to put it back. So I'm going to have a denominator of 50 for the first draw, and I have a denominator of 49 for the second time that I choose a cupcake, or Pam chooses a cupcake. So I want the first one to be chocolate with chocolate icing, and that's 10. And the second cupcake needs to be chocolate with vanilla icing. There's 8 of those. So I have to pretend I got a chocolate with chocolate icing on that first time that I chose. So there's still all 8 of these left. And that is going to multiply to give me 8 out of 245. I actually will choose 1 cupcake, determine the probability that it will be chocolate or have chocolate icing. So when I'm looking at or probability, look at your reference sheet to help you guide your thinking on this. I have to figure out, is this overlapping or non-overlapping? When I have an or probability, I have to figure that out. So can a cupcake be chocolate with chocolate icing? Yes. So that is overlapping. The probability that it's chocolate is 18. Let me do this. The probability that it is chocolate plus the probability that it has chocolate icing minus the overlap, the probability that is chocolate with chocolate icing. Probability that it's chocolate, 18 out of 50. There's 18 chocolate. Probability that it has chocolate icing, cake could be chocolate or white, so there's 22 out of 50. And I have to subtract off the overlap, the chocolate cake with chocolate icing, which is 10. Because I've counted this when I counted it as a chocolate cake, and I've counted this group when I counted it with chocolate icing. So I'm subtracting off that 10 out of 50, and that's going to give me 3/5. Problem 8, consider the bag of marbles below. Now I'm going to go ahead and write this in here. I have 3 black marbles. I have 3 white. And I have 4 striped. So I have 10 total marbles. Determine the probability of selecting a black marble and then a second black marble without replacement. I know the first time I draw, I'm going to have 10 to choose from. I'm not going to replace, so the second time I draw, I have 9 to choose from. Probability of selecting a black marble would be 3 out of 10 on that first draw. Now, I'm not replacing it, so I have to pretend I actually got a black marble. Well, now there's only 2 of them left, so the probability that the second marble is black is 2 out of 9. multiply that together, you get 1/15. And problem B, here, determine the probability of selecting a black marble, then a striped marble with replacement. All right. If I'm replacing them, I'm going to have the probabilities both out of 10. Probability that it's black is 3 out of 10. Probability that it's striped is 4 out of 10. And remember, I'm wanting both of these to happen. Again, my problem doesn't come right out and say the word and, but I could easily stick like that in there. Determine the probability of selecting a black marble and a striped marble with replacement. So this is going to give me 3 out of 25 for my answer.